other than my face is in the corner. All right, so day 3 of notes, but it's worksheet 2 because we took 2 days to do worksheet 1. So hopefully that's not too confusing. You can keep up. First thing I need to say is the printer messed this up. Right? Blame the printer, not me. Number 1 needs, it looks like absolute value bars. It looks like 2 of them. That's not what it is, but that's what it looks like. Like number 7 has the absolute value bars. Number 1, it failed to print the double bars thing. That's the only new thing for today, and we'll talk more about it in a minute. Before I forget, number 17 also needs the double bar thing. All right, we're going to do 1 through 16 together because you already know this stuff. You don't really know number 1, but hey, it's multiple choice, process of elimination. We can figure this out. It might be easier to start with the letters. I think that. So let's start with the letters. A is the quadratic function. So look at the functions 1 through 8. Which one is the quadratic function? 4. All right. How about the square root function? 5. Yeah, you did this last year. You guys hammered this a lot. Letter C, cubic function. 8. Some of these are really easy. Like, yeah, cubic. There's a cube there. Can do this. Constant function? 2. Not 2. 6. So 2 isn't constant. 2, it changes. Y value changes with x. 6, the y value doesn't change at all. If C is 12 or 6, it's constantly 12 or 6 or whatever it is. So the constant function is number 6. Absolute value function? 7. Okay, now we get to some weird names here. Greatest integer, we haven't seen that before, so that's probably the one we don't know. Probably 1, but let's hold off just to make sure. H, reciprocal. Which one is reciprocal? 3. 1 over is reciprocal. And identity function. You may not have called it that before. It's number 2 because the only one that's left. Identity means that y is going to be equal to x. So y is going to be identical to x. Whatever x is, y is identically so. So that's the identity function. And then the only one that's left is the greatest integer function. We've not talked about that before, but process elimination. By the way, it's also called the step function. The step function. And that'll help when it comes to matching the graph. You can probably peek ahead and pick that one out already. So, any questions on those? Like, I hope 7 of the 8 were familiar to you. Maybe in Algebra 2 you did like the matching cards where you had the name and the picture and the equation. You got to match them all up. In fact, I probably have some back there, but I don't think we need to take the time to do that. 9 through 16, we're matching up the pictures now. So I guess let's do the same thing. Let's start with the letters. The quadratic function. So looking at the pictures now, which one of those pictures is the quadratic function? Which one? 13. It's like, I hope this is so easy, that's why no one's talking. It's like, this is dumb. Why are we doing this? Which one's the square root function? It's a little bit trickier now. You remember what the pictures are? 11? Yes, 11. 11's the square root function. It's coming back, maybe. Cubic function? Not 10, it's 16. 16 is the cubic function. Constant is probably easier to even identify on the graph. So which graph is not changing? Number 9. The y value isn't changing. It's constant. Which one is the absolute value function? 10. All right, this is how I remember that. The absolute v for value, that big V there. This is the absolute value function. So 10 is E. overkill with the v stuff there. Greatest integer function, we also said, is sometimes called the step function. So 14 looks like steps, and that's why it's called the step function, because it looks like steps. We'll talk about why it's called greatest integer in a moment. Oh, while we're here, I may as well give away my fun name for it later. It's also called the birthday function. Birthday function. That sounds interesting. We'll get there in a minute. Which one's the reciprocal function? There's only 2 left. And one looks like a line, so it must be 12. And then the identity function, again, that means if x is 1, y is 1. If x is 2, y is 2. They're identically the same, so that's 15. Now, again, 7 of the 8 of those I hope you already know, or in the last 5 minutes you're like, oh yeah, I remember what matches up with what and who goes where. Let's now take a couple minutes to talk specifically about the greatest integer function. Unit 1, Day 3. Step function, greatest integer function, birthday function. But that's not 3 different functions, that's 3 different names for the same thing. Probably should have started with greatest integer. That's its official name. The step function is sort of a slang name, but that everybody knows. Like if you say step function, everybody knows exactly what you're talking about. Everybody in the math world, right? Your younger brothers and sisters have no idea. But in the math world, people know what you mean if you say the step function. I made up the name birthday function, so that's like me only. So if you use that word somewhere else, they're going to be like, what are you talking about? That's not a real thing. And you'd be like, oh, that's what Mr. Wolf called it. Well, Mr. Wolf made up that name. But I think it helps explain it when we get there in a moment. All right, so it's the one with the 2 bars on it. And one way to say it, and why it's called the greatest integer function, is that you round down to the nearest integer. Round, but not to the nearest integer, down to the nearest integer. So you're always going down the number line, or if you're looking at a number line, you're rounding left. So we're going to look at some numbers between 5 and 6 in a minute. So you're always going to round down for the greatest integer function. And there's not really a good way to say it. Like you say, what's 5.2 squared, or the square root of 5.2? I guess you say, what's the greatest integer of 5.2? Meaning, what's the biggest integer that's to the left of 5.2? So there's 5.2. So the biggest integer to the left of 5.2, if we round down, would be 5. What about the greatest integer of 5.5? Well, normal rounding, you would round to 6, but we're not rounding, we're rounding down. We're going to the left. The greatest integer before we get to 5.5 is still 5. And 5.9999. So yeah, you're right up next to 6, but you're not to 6 yet, so you have to round down to 5. Okay, so let's talk about why I call it the birthday function. The day before your 12th birthday, how old are you? The day before your 12th birthday. You're still 11. It's like you're 11.99 years old, but you're 11. When can you get your birthday? When can you get your birthday? When can you get your driver's license? You got to get to 16. You can't say, well, 15.5, that rounds up, right? judge or DPS officer person at the office there. Like, no, you got to get to your birthday before you're 16. 15.99, you're not 16 yet. Or whatever, lottery and alcohol, whatever those significant steps are, you don't get to round. You got to get there before it counts. Same thing here. If you're not to 6, you're still 5. Right? It's frustrating for little kids. How old are you? Well, I'm almost 8. Yeah, well, you're 7. So birthday function. Yeah. So birthday function, silly name. Nobody else uses that, but I think it's helpful to remind yourself that you're rounding down. If you're not 6 yet, you're still 5. Sorry, kid. But when you do reach 6, what's the greatest integer of 6? 6. Like sometimes that one throws people off. Like, oh, am I still rounding down to 5? Like, no, you're 6. Congratulations. All right, now if that wasn't confusing enough, the negatives get a little bit strange. Or they're not strange, they still follow the same rule. So I got to round down or round left. So if I round down from negative 1.8, that's negative 2. This is where the number line's helpful, because you're always looking to the left. Okay, well that one makes sense because that's how you would round that anyway. What about rounding down from negative 1.1? That's also negative 2. So it's the negatives that are extra. They seem weird. Be careful with the negatives. And the birthday thing doesn't work either because you've never been negative 2 years old. So, all right, so that's the greatest integer function. It's called the step function because when we graph it, it turns into steps. So you saw the graph. Let's do a little more detailed view of it. And to me, the easiest way to graph it is to not do the negatives yet and not do 0 yet. Let's look more like at 1, 2, and 3. So when you turn 1, you get to claim that you're 1 years old. When you're 1.5, well, sorry, you're still 1. When you're 1.8, 2 days before your birthday, you're still 1. When you get to 2 years old, though, then you get to be 2. So we're going to back up and put an open circle. So right up until your actual birthday, you're still 1. Then when you turn 2, then you get to move up. And you have to say you're 2 years old all the way up until your 3rd birthday, and then you can jump to 3. And so on. Yes, sir.
You always have to have an open circle when you graph it.
So you have an open circle on the right end, because that's when you make the jump. So when I'm graphing it, I graph it that first, and then I can take the pattern and back it up. Because in the negatives, it's a little bit weird, but if you got the pattern down, then it's not too bad. Even 0 is not terrible. You're 0 years old until you turn 1, and then you get to make the move. Again, in the negatives, that whole birthday thing doesn't work, but at that point, you got the pattern down, so just copy down the pattern. Step function, greatest integer function, birthday function. Yes, ma'am. Because as opposed to a closed circle, well, one answer would be if this was a closed circle, then this thing wouldn't be a function because it wouldn't pass the vertical line test. And the other way is, well, on your 3rd birthday, if someone asks you how old you are on your 3rd birthday, like you always get this question, right? Like you're excited, you are 3 now, right? You're not 2 anymore, you are 3. Now, right up until your 3rd birthday, like the day before your 3rd birthday, and someone asks you how old you are, well, if you're a kid, you're going to say, I'm almost 3, which means you're 2. You're still 2. So right up until you actually get your birthday, so the open circle means don't include that, but everything right up to that. So the open circle means include everything up to there, But once you get there, you get to jump up and be 3 years old. Congratulations.
How come on the negative, the open circle is still on the right?
So it's still on the right because, let's see, at -1, the greatest integer, well, the integers are always the closed circles. The integers are the easy one. One way to teach it is put dots on all the integers and then make your stair steps. So the closed circles are always at the matching integers, -1, 1, -2, 2. At -0.5, well, you're still rounding down to -1. At -0.1, you're rounding down to -1. So the negatives are the hard ones. That's where the number line is helpful. The greatest integer of -0.1 is -1. You gotta go left to the integer. Oh, we locked him out because we were being secure. You can leave the door open. There we go. Other questions on step function, greatest integer function? You know what? Before we move on, since we're right here, grab the worksheet and do number 17 real quick. It's 4 questions. They're all greatest integer questions, but they'll get a little practice in. So there's answers A, B, C, D. Hopefully you got those. Let's jump back to the notes page. You're going back and forth today. Roman numeral 2, we're going to do some transformations. You did a ton of these in Algebra 2. So this usually goes really quick in Pre-Cal because your Algebra 2 teachers are all stars. All of them. I don't care who you had. Some of you are like, I don't know. Others of you are like, yes, Miss Craig was an all-star. Y equals A times x minus B plus C. Okay, now's your chance to prove that your Algebra 2 teacher was an all-star. What does A do? So even if this is like square root or squared or absolute value, if there's a number out front, what does it do to the graph? Stretch or compress. Good. Stretch or compress. How do you know which one it does?
If it's a fraction.
Let's say greater than 1. Yeah, fraction's a little bit dicey because if it's 9 halves, that's a fraction, but it's a stretch. So stretch is if A is greater than 1. Compress if A is less than 1. Not less than 11, not less than 1. But I also heard another word that A can do. Somebody said it. If A is negative, if A is less than 0, negative, then it's a flip. So it's a stretch or a compress, and it could be a flip. So it can stretch it and flip it, or it can compress it and not flip it, and it all has to do with the value of A. You guys are experts. How about B? What does B do to the graph? Left or right? So left or right. Sometimes we'll call that a horizontal shift. Although something weird about B, and it's why we always write it as x minus in there. If it's x minus 3 compared to x plus 3, which way does x minus 3 go? Right. Good. Look at you guys. And which means x plus 3 is left 3. Stop me if we need to slow down and explain this some more, but you guys sound like we're good on this stuff. How about C? What's C do? Up or down? Vertical up-down shift. And that one's more normal, right? So if it's a plus 7 at the end, that moves it up 7, what you think it would do. If it's minus 7, it moves it down 7. Now, we use this 2 different ways. One way is we give you the information and ask you for an equation. The other way is we give you the equation and ask for a graph. do some equation writing first. Write equation of a cubic function with vertical stretch 3, horizontal shift of right 5. Write the equation of a cubic function with vertical stretch 3, horizontal shift of right 5. Okay, let's see here. Cubic. I know what cubic means. So, cubic function means something is cubed. That seems easy enough. By the way, make sure you put y equals on there. If you don't put y equals on there, then it's not an equation. This is a very frustrating thing to make a 99 on the test for. You get everything right, but you left off the y equals, and I took off a point because I'm mean like that, and you make a 99. I mean, congrats on the 99, but what a frustrating thing to lose a point on.
Can you write f of x?
You could write f of x. That would still be an equation, but write one of them. Yep. Okay, so cubic function, got that part down. Vertical stretch of 3, what's that? How do I make that show up in the equation? Wait a minute. Vertical stretch, not a vertical shift. I don't want to move it up 3. I want to stretch it 3. So where's that 3 go? It multiplies out front. As opposed to a vertical shift, which would be a plus 3 at the end. Horizontal shift of right 5. How do I accomplish that? X minus 5. So, nice, pretty color-coded equation there. All right, those are pretty easy. Let's do a couple of graphs. Let's graph y equals negative 1 over x plus 2. Okay, so the parent function, you don't have to graph it, but I like to do just a quick little sketch because my brain starts thinking, all right, I know it's reciprocal, I know it looks like that, now I've got to do some changes to it, but my graph better look something like that when I'm done. All right, so tell me what have I done to that graph? What are the changes? What are the transformations? Up to? And what else? The flip, that negative sign out front means we've got to flip. So up to, normally there's a asymptote there, so I'm going to move it up to. And then flip it, so this branch that was up here is now going to be flipped over to the bottom, something like that. The branch that was on the bottom is now going to be flipped to the top, something like that. So it's flipped, and I moved it up to. The most common mistake in this section is how do I say this? People will write this and get it right, and then not do that on their graph. It's kind of confusing as I'm grading it. I'm like, good, they recognize all the transformations, and then I guess they just forgot to do one of them. So on this section, when you finish the graph, take 3 seconds and make sure that it did what you said it would do. Because almost everyone gets this part right. It's just, do they make the graph reflect those changes? Reflect. Number 3, and last. Let's graph f of x equals 2 times the absolute value of x plus 1 minus 3. 2 times the absolute value of x plus 1 minus 3. Let's see who's here today. If it matters to you. So there's the three transformations. There's a stretch by 2, a left 1, and a down 3. I guess I could have called on somebody for the parent function, but it's absolute value, so that's the v. You don't have to graph the parent function, but you should at least be visualizing what it looks like so that you can make the changes to it. All right, down 3 and left 1. Down 3 and left 1. That's kind of my new starting point. I don't think it's officially called a vertex for an absolute value, but you would know what I meant if I used that word. It's the vertex, yeah. Again, not exactly right, but left 1, down 3, that's my new starting point for sure. So how do I stretch 2? That's true. How do I accomplish that when it comes to actually graphing this thing? What do I do with that 2? How do I handle that?
Oh, instead of going over 1, up 1, you go over 2, up 1, right? Or is it over 1, up 2?
Let's see. So you're on the right track. There's my normal points. Although, be careful, they're not really ordered pairs because we've moved it. But that's sort of like directions to the next point. Normally, for absolute value, yeah, over 1, up 1, over 2, up 2. But we're multiplying by 2, although the question, that's the right question, is who's getting multiplied by 2? The x's or the y's? And you already told me that it was a vertical stretch, so that's sort of your answer. Who's going to get multiplied to accomplish a stretch in the y direction? The y's. So we're going to take that 2 and multiply it to all the y's. So from my starting point, so again, there's not the point 1, 2, but I am going to go over 1, up 2 from the starting point on both sides. And then I'll go over 2 and up 4 on both sides. And I don't really want to do 3, 6, and 4, 8, and so on. We've got enough points to see what's going on here. So there's my picture. Again, take a moment to make sure it matches everything you said would happen. It's been stretched, it's left 1, and it's down 3. So I feel good about that answer. All right, today's assignment is worksheet 2. And just as a reminder, worksheet 1 through 4 are due next Friday. That was way too long to wait to take up papers, but whatever. So, you got 10 minutes left or so. You could certainly finish the first page because those bottom 5 are pretty easy. And then if you could graph 1 per minute, you could finish before we leave. I don't know, it'd be close.
The answers online.
The answers are online. Yes, the answers are posted in Schoology.